I don't know why it says 0 viewers. I do see 1 viewer on Twitch, so that is you. Okay, so I was interrupted before and I had to pause the stream, but now I'm back. So now basically what I'm thinking is actually I think what I've done here should probably be reverted. Let's see. Cmd git diff. So what I basically want here is I want to undo this one function. Because what I would instead do is I would have this result signal. Wait. I would want result signal to be passed as a pointer and not result value, I think. That way it's gonna be a bit better. Because writing the result signal is usually more rare, right? So have eval statement. And we'll have runtime signal. Signal, right? Okay. Runtime signal, runtime signal, none. Okay. Signal like this. And for now, I guess I can just not print the AST. Okay, so what I will need is value type. No, I will need statement type return signal, right? Okay. Okay. Now let's include what's up, Demon? Let's include the parser here, and now this, instead of doing lexer, it's a parser is reserved keyword. Makes more sense. And I guess instead of calling this parser, I would just call this is reserved keyword. That makes more sense. And now to the reserved keywords, I will add return, break, and continue. And I also add while and for. While and for. Okay. Okay. Result signal. Okay. So this should do it. And now what we need is for sure, we need return signal. Return signal. Or maybe I'm actually incorrect and what I had was better. So what I'm thinking is, because if we happen to have, like, let's see here, right? If we happen to have a signal that is set, right? Then we want to, no. If the result signal is set, then we want to out the signal back, right? And we want to return the result, right? So I guess I will make this a macro. Define. It's like return of signal. And it would just be this thing. This ring. Yeah, okay. So this would do it, right? Return if signal after each thing. Oh, I guess I should do wrap this in a do while. While false, right? Return if signal. So now I can actually, I'm actually expected to have the semicolon. So that's probably fine. And then for when we are evaluating statements and not just expressions, right? Declare would not have it, assign would not have it, function call would not have it, eval statement, param. function scope could have it. I mean, no, actually here, like, if the result signal equals return, huh? Not entirely sure. I guess this one will stop the signal. Should be. Because we basically, some things need to propagate signal. Propagate, maybe. Propagate. They need to propagate it up. So we just, if we hit a return statement, it means we want to return every statement until a function call. And then I guess what I would do is propagate like this, except, and this would be return signal isn't 0 and it isn't accept. Return signal isn't accept, right? And that way, we don't we would propagate the signal until the accept. So in this case, we would propagate everything, right? In this case of a scope. And in case of an if, we would propagate everything, right? Propagate every signal. And then, rather, maybe this would be, don't know. I guess I'd like this to be a one-liner. Can I do that? I don't know. But I guess this would be catch signal, right? Catch signal and propagate signal. Propagate signal would be without the accept. Kind of duplicated code. So I guess what I would do is I would do catch signal 0, right? This is what it would be. So in the case of propagate, we would just say propagate, right? And then in case of function call, we would do catch signal, right? Catch signal, runtime signal, return, right? I guess in case of a function, I would want to really catch any signal because break and continue wouldn't do this. I don't know. Yeah, anyways, but return signal just will write to out signal equals. Yeah, I got Twitch working. It's either I lowered the bitrate because it was too high for Twitch, so maybe that was that. Or just some other Twitch internal thing that I had no control over, so. Who knows? Return signal. And value would be invalid because this is not an expression. Although it could be an expression, right? And at that case, we would want to return the result, right? So. Interesting. So then, how would I do this? Well, let's actually define all the keywords. Or maybe first I just showcase what I've done so far. Because I don't think most of you have seen. I can assign a function as not constant. Oh, yeah. I undid my work for function calls. Function call. So in the case of a function with assign, function, scope, statement, declare, basically I would paste this. And in case of a declare, I would just have isConst as a parameter. Oh, this is also not true. Okay. And this would be value function, right? Like this. Okay, so we do have functions. And we have the correct syntax for them. And we also do have dynamic functions. So you can either make it a const with this syntax, right? Or you can just declare it as a thing that you can later change. So like hello 123 here, there's a different thing than a hello hello here, right? So if we call this, it actually says hello first, right? And then it says hello updated, which is the reassigned version. So you could see how useful this could be technically, right? And now I'm trying to get returns working, continue, break, and generally improve the syntax. And I also wanted to add static typing today, but I actually don't know how the returns will, how long they will take. And I know that while and for and continue and break are basically already here. I don't know what I will do for because I don't think I will do. They could do like for e equals 0 e. Something like this I could do. I still have to add those operators, which I also wanted to do today. So maybe I don't do type safety today. Fine. And I also could do like for e equals 120 or something, right? And then I could do this operator for if you want 1 to 20, and then this would be 1 to 19, because then you could do just count, right? From 0 to count or whatever, that might be useful. I don't know, because I'm not really sure how you'll do the for loop yet. The while should be simple because it's just while true, right? While an expression. We keep looping it. While the expression is still true, we iterate. So that should be easy. And then the ones that I'm really not sure about as well and break, right? But I think they can be done fairly easily, so. With this like signal propagation system that I came up with. Yeah, because at this point I really just like write my own code because like some of the parser code I have looked up mostly. Because I wanted to do the IST right, but I never done the before. But now that I know how this actually works, I think I can already write my own stuff. So also the syntax is completely my own implementation, since the video I watched was like more like JavaScript, not like this is more like JI, right? Okay. So what I was doing was I guess what I should do now is add all the identifiers that I had. So now return is statement return signal, right? And the signal would just be return signal equals return signal. Yeah, it's like runtime signal return, right? And then the same goes for break and continue. Break and continue. Okay. And now I'll do for. So for and while. Actually, I don't think I want to do this here because those are for. Those are primary, so this is for mostly for expression parsing. And I would want this to be in a read statement more. So here, right? Like. So if we accept, I guess else if we accept a keyword lecture. So like this. Okay. So let's say just control flow here. Yeah, okay. And now we'll also have a while loop and a for loop. Right. Hmm. Okay, let's work on the runtime for now. Although maybe I can do, I guess for loops I'll leave us to do, and while loops I will do now because they are pretty straightforward. So I would add for, or I mean while loop is pretty straightforward, and then scope is what I need, condition, scope. Okay. And I think the way I will do static parsing is basically I will have a parser scope that stores all the declared variables and their type. And that way I'll be able to do all the type checking necessary, and I will also be able to augment the AST with the types, which should allow me to do more things. And probably will also allow me to do like optimization work later. But I think I will want to compile this to bytecode eventually anyways, but for now we are just evaluating the AST as it is, so that's how it goes. And okay, let's do while. And while would be an expression. No, wait one. In parser, we could copy the if statement, and then we wouldn't accept else. We did this. This would be a while loop. While. Also, I think I will just call this result here. Result. Like here. Parser error. That's code prime. For a while. Yeah, okay. And now here, one sec. expected. So for keyword, it's not yet supported. Okay, and we get some compilation problems, probably. If thanks read statement is not defined somehow. Have I included this here? No. Yeah, I'm getting errors in completely unrelated. I did something that breaks. So it's not a runtime signal, it's... I don't get it. Is runtime value stuff? Oh, it is actually in parser. Funnily enough. And not... Well, I don't know what's happening here. Is it because of reserved keyword? But... Lexer is only including the parser in the CPP file, so that shouldn't be a problem. Unless I missed the pragma ones or something. No? Okay, let's look at the output of the compiler and maybe we'll see format string. Oh. Here we have the problem. Oh, okay. So I haven't closed the scope here somewhere. Oh, it's here. Yeah, I wish it just like pointed me to like Lex token here or something instead of like entire like all other files. Fuck Visual Studio. Okay. So what I want to do is... This whole propagation is kind of hard to do in C syntax. I don't know what to do about it. So in runtime... Well, let's first do a while loop. So... While loop... Like here, while condition, scope... While... scope print. So this is for printing. And then for printing... Return signal. Just actually... Oh, I don't know why I put it here. Oh no, that's correct. Because it is a statement, so... After function calls where I would add it. And what I would print here is just... Would be similar to the identifier, right? Because I would just do... I will just return signal %u, and it will be statement return signal. And I will mark this as to do add or print the name of the signal instead. So that's useful. Okay, so we have return signal. Think about it. Okay, yeah. So in parser we need to add expect semicolon, right? Expect semicolon after continue break return, right? So return will need to return a value eventually, but maybe let's not do it. Let's first finish the while loop, I think. Just doing while loop is probably easier than doing. Okay, so we have the while loop here, right? While. And a while eval type equals runtime. So now here eval. Oh yeah, I guess I should make a thing where the static bool is true. Statement or runtime value is true. Runtime value. Value, right? And now switching on the type value. Type case value type integer will return value integer is 0. Decimal will do the same. Decimal. By default we just return false. For functions, I think we'll just always return true. I guess I know because this is a bool, but return string. I guess for string we'll just say is the string actually with size. So yes, I can just do this. And functions will always return true because they're always a thing. We don't technically return address of function or anything like this, but function is just true. Okay. And now instead of doing this eval type equals integer, we just say eval like this. Runtime value is true, eval address of eval, pointer to eval, I guess. And then we'll do the same here. And then while it's true, then we eval on the statement. And now if the signal result signal is equal to result signal runtime signal break, then we just break. If it is a signal if it's a signal continue, right, then we continue since it's just fine, and otherwise we propagate the signal. So if it is set to something else than break and continue, we would propagate it up. And I think that does it, right? So also this should be while condition and this should be while scope. Technically, this would still work, I think, because both are true. And now what I can do here... I would really want some syntax highlighting for this. No, can I enable something? View? I don't know, just enabling like C syntax would be probably enough. But let's do while e is smaller than 10, we will print e, and we will set e to +1 like this, and I will initialize e as 0, right? And I guess I did this like here. I see, okay, so the problem here is that I actually have to eval the statement like this. I see, okay, so let's just do true. And now let's do this, right? If it isn't true, then we break. Because I was not getting re-evaluating the statement, I was just checking the initial value. Okay, we have while loops. Great. Now let's see if so let's do this, right? Let's check if e equals 3, then we will continue because we don't like freeze. Right? And then if e equals 7 after the print, we'll break because we don't want to go up to up to 10 or whatever. And let's see if that works. And continue breaks it, interestingly enough. Interesting. Return signal. Interesting. So we return. Let's print the AST tree. Let's see what it actually looks like in practice. So we'll have our AI script test. I will print the statement, right? Okay, so we have a condition, we have a scope, we have an if. Return signal of type 3. So e equals... So if a equals 3, then return signal of return signal 2. So I bet that means it went up to the if statement, right? And then the if statement wasn't able to propagate it up correctly. Well, I think what I will do instead of working with this, it's like... This is kind of annoying to deal with, honestly. Let's just do... I should go to the runtime. And instead of dealing with all this, like, propagate signal bullshit, I'll have, like... In runtime, I'll just have struct eval result, and it will be a runtime value. And runtime signal, right? And instead of having to pass the out signal here, we'll just pass it like this. And now we'll no longer need to pass the last arg. Okay. Okay. Result signal equals this. So let's say current result. Say condition eval like this, and then we'll do eval result like this. Say eval value, condition eval, and this will be scope eval, right? Scope eval equals runtime signal break. So like this, right? So for now it should do nothing. Eval statement, let's think about it. Okay, so this would be eval result, value xt. Just call this eval instead than eval. Okay, eval statement. Yeah, so this needs to be eval. Right, and now this would be eval result var eval equals this. Our eval value. It's weird because by default expressions can only so expressions can only return values and statements can only return signals. But since return has to propagate its own value, up the function, up the call stack, it also has to propagate the value, but well, whatever. Eval statement, eval result, eval. Yeah. Because I know, like, for example, here, like print, which print takes an expression. So I know here's always an expression, right? The statement is always an expression, so I know I don't have to check for signal propagation. But this is like a bit even result, left E. I guess that's fine. Left value. It's a bit weird that I would like it's a bit non-robust, I guess. That some things would not check for it. Could be error prone, I guess, is the biggest thing. So eval result equals this. I don't know why I didn't do that. Okay. Here we take the value. It's a bit of a shit show that I have to do this. This would be eval result, eval type. Here I would switch on the eval value type, right? And then base of runtime integer. I have never supported a unary op for other things. It's probably fine, but so it would be eval value type, right? And then I also would do decimal for decimals, I think. Well, that's kind of weird that you would negate a decimal, but that's fine. I guess what I could do for negate is just... Would I always want to make it? Huh. I think what I would want to do here, always, is in the case of negate, right? So for this type, I would just want to make this so it always makes it an integer. Runtime type integer. Actually, maybe I just call this runtime type. Huh? Is that fine? And yeah, I would want this to always basically check for so we made this function that is runtime value is true, right? So we'll check this and we would negate it like this. Result value like this. Okay. So that does it for me. This whole thing I just remove now. Okay. So what I think I have to do is propagate. So I would do bool should propagate with the value, the eval result, eval, right? And now return eval type. So if, I guess if signal and eval signal isn't the exclude, right? Right, so I would pass it a runtime signal exclude. Or no, maybe I don't do that. I'll say result equals eval, right? I guess we would return the eval, right? I think that does it. And then it could just be this, right? And, okay. Okay, so now if when we propagate the statement eval result eval equals this, we just propagate the eval like here. So except is undefined, it's because yeah, I don't really care about it anymore. Yeah. So now basically if the signal is something, then we return the eval instead of our result. Yes, okay. So now this is eval, like this. And this is really because okay, for scopes we always want to propagate, right? For ifs, we know this is of type scope, so we would never have to propagate. Although no, because scopes propagate their things. So I guess all statements should propagate, and all expressions shouldn't. Is that what it is? I think so. Okay, so now we would propagate the scope eval in this case. And condition, which is mistyped. Condition doesn't have to eval. This doesn't have to eval. This is where actually having a type. So if I had actually spread this by like struct expression, right, struct statement, and I would have, or maybe union, right, and I would have all the ones separately, then I would know better, but scope eval assign declare don't have to function call is where it would do this, right? So we would do eval result, eval equals this. And now if eval signal equals return, that means we actually want to eval signal set to runtime signal none, because we don't want to propagate up anymore, but we want to return the value of that propagation, right? So we return eval then, okay. And then in this case, if it's not a return, we would propagate up. I guess what I would want though is I would want them to have priority, so return being the highest priority would never propagate things that are lower priority. So instead I would say low. Lowest. So we would say eval signal is greater than, you maybe say current, right? Current. And propagate any signal would just say propagate signal eval 0, right? So this would basically mean maybe it would be propagate signal X or something. So in this case, when we have toast, the lowest is the highest priority is break. So anything that is bigger than break, we would propagate up. Current. I guess let's say lowest. And then in this case, we would not want to propagate anything lower than return, because we wouldn't want to propagate, continue, or break past the fucking function. That makes no sense. So that is what I will do. And I guess in this case, maybe it's better to say, we'll take the maximum of the two, right? Continue and break. A break has higher priority than continue, although it shouldn't really matter, because they would never be propagated at the same time. Right? Propagate. Oh, let's see if our while loop started working. Value. Thanks. Oh, I think it overpropagated actually. So Let's actually add so in the parser where we return signal, right? Let's actually add it a value, runtime value, or rather statement value. And in parser now, when we do return, return like this, right? We would say statement value equals get read expression, right? Xer arena. And now if value, then we set the value to the value. Right. So I guess if Xer accept token semicolon, right? If we don't accept a semicolon yet, then we would expect it to have an expression. That way I don't have to do optional expression parsing. That should be good. Let's actually see if that works, because that would be pretty fucking epic. So I know that the continuous still doesn't work, so I'll just comment it. But I will say like free. That would be a function that returns the free, right? And then we would print free like this. Does this work? Doesn't. Primary parsing of this token is unsupported. There's some problem with that because it doesn't. Yeah, it uses log error, parser error. And then same goes for here. So where do I also use log error? Here, that's fine. Nowhere else? Yeah, okay. And now it seems like our... So when we do print, it does read expression, right? It's because function calls are currently... I think they're currently... No, they should be primary, right? Parse primary is where it is. Lex token type string, value, identifier. Where do I have function calls? Function call. Yeah, I have some unresolved errors here. That much is correct. So I have to move function calls to be in parse primary because I want to accept function calls as arguments, right? And here we would say basically so here if we accept a token open parent after the identifier, we would just make this a function call, and otherwise we would make it an identifier. And I guess here I would if like this, and this would be identifier. This would be like token auth, right? Okay. Okay, do we print a free? We do not. primary parsing of this token is unsupported. So let's see if this actually even compiles. Like if it actually gets called here. It does, and the token add is free. Okay. And what is lecture add? Lecture add is already past free. Interesting. So this tries to read an expression and it fails. Oh, I see. So basically, I have not handled. I have not handled expression, like argumentless functions correctly, is what I'm thinking. And I think what I just need to do here is, instead of copying the token, I need to pick it. And then I guess I need to pop it. Maybe I save the state, right? Parser, save state, state equals lecture. Wait. So this thing here, I'll move to the beginning. Lecture store state, parser store state, arena. Okay. And now if we have not popped the thing, we would just do restore state, parser restore state, lecture arena state, right? And it should basically mean that we can now do optional expressions. So it expects a semicolon after call, which is incorrect, since a semicolon, because expressions themselves will expect so after statements they would expect a semicolon anyways. And now it seems like we were finished, we found the propagation. Okay, it seems like now we are working. It's just the propagate signal is not exactly correct. So let's see, return result value equals statement return signal value. Now if result, so if this is a thing, then we would eval result eval equals. And now the funny thing is that statement scope, right? And then this eval could technically have its own signal, right? But we just accept that expressions will not. So signals will not be emitted by expressions. It's what we'll basically accept as our assumption, right? What we could do instead, I guess, but that's dumb. We don't want that. But we could do something like return break or whatever, right? And then if this one would be a higher signal. Yeah, I just don't see a use case yet, but maybe there is one. Maybe there's like some new keyword we would have that would use this, but as of right now, not really. And we would do eval value. Okay. have a Stack Overflow because we have evolved too many things. So let's step through this. So and parser. In runtime, I'm sorry, we'll check into the function call, right? Okay, so we don't have a param, and then we push it over on scope. Okay, we come here. Oh, yeah. I evolved the wrong statement. Instead of evaluating the value, I was infinitely evaluating the return signal recursively. Okay, it just works now. Great, we have a return. And let's see if we also have the while loop handled. No, we still freeze on 3. So are we in a while loop? Oh, yeah. So this was all correct. I just changed the order of them and didn't swap the keywords. So now should actually just work. We should skip the. Oh, it doesn't though. This is not a bug with the parser, it's bug with this code because we need to do. We basically need to print like this, and then after adding, if it's 3, then we break, and then 7 should be here. Right. So now it should finally work. We have not skipped the 3 though. Let's do this, I guess. Yeah, 1, 2, 4, 5, 6, 7. Okay. Apparently I can't write simple while loops, but holy fuck, this becomes a language. So for loops I can do, but maybe not now. Okay, so this is completely done, right? This is not done because we haven't done the for loop. This is not started. This is not started. And I guess we could. You could add this to this pack. And then those I would want to expand later. And actually, there's one thing I wanted to add here. And it's CMW port this to triggers. Maybe AI? That would be pretty epic, but I think I mean, maybe stress testing it in an actual game is a good idea, so maybe it's actually the most sound idea to test this in CMPW, right? But also, I think developing this language to a point where it's actually like, I know it's like pretty robust is probably very important too. So, but okay, I will just say git add git commit add support for return continue break while improve function syntax and allow non-const functions. Okay, that's a lot of progress, but we haven't done static typing yet, and I wanted to do it. I think for loop I will not do yet because I don't exactly know what syntax I want for it. It's basically equivalent to while, but it also has some like, we either do this syntax with so let's say here, maybe here. We can either do for e equals like 0, e less than 10, plus e, like this, right? Or we could do e maybe like this, 0, 10, right? And then for e 0 equals 10. So this would be this range, and this would be this range, right? I'm thinking this is probably better. And so let's just add a comment here. Can either do, or we can do only. I'll say second is probably what we want. So this is the for loop. And I think I will lose my mind because I don't have. Oh, I guess I don't have colorization, so it's pretty annoying. I don't know what where comments are, but okay. And now for those are for loops, and then types should have for type equals value or var equals value or var type, right? Or var const value, right? So those are the 4 kinds. Init to 0, init value to 0, and then this would be explicit or fully explicit, right? And this would be init type to what the value is. So if we say 1.5, it would be decimal, this would be an integer, and string would be like this, and then function call would be like this, right? Okay. I guess I don't think we have support for. I just realized that I don't think we have support for single statements, right? do we? Because if there's like, if there's scope just like this, I think this is currently an error because it would expect. Yeah. So see, if I do an empty scope, it's just stuck. It doesn't know what to do. Oh, actually, never mind. That's because of... We are stuck because of comments somehow. Oh, I see. So this basically... Because read statement eats this, then it expects this would be the close brace, so it's this, and then we never open the comment correctly, I guess. I don't know. Another thing is fix the freeze. I guess this I will just mark as complete and fix the freeze on empty scopes. Okay, add support for optional statements. We already have optional expressions. And then what we want here is fix or like finalize for syntax and implement the for loop. Okay. Oh, I removed the wrong keyword here. Return is supported now. Okay. I guess eventually we also want to add support for condition then else value then value operator. I don't remember what's the name of this operator, whether it does then and else for an express, like it's like an inline expression if. That's something I should do. And then I don't know. What else do we want here? Okay. I think that's it for the plans. Okay, let's adapt the parser a bit because we no longer will have a declare like this. We would just have, we'll just have colon like this, and we will then have sign like this. Colon, okay. And then here it would be colon and a sign, right? This is just always a colon now. Colon 1 like this. Okay. And now what we do is we accept the token. So let's first actually have a type here, right? Type, runtime type here, right? So this would be, so we accept colon first, right? And now we either accept another colon for declared const, like this. Okay. And now if we instead accept and assign, we also have an implicit type, and if we instead accept identifier, non-reserved identifier, so I guess this is the primary case, right? And then we do this, and we can accept an identifier, which would be just type, lex token type, like this. I think what I need is I need a function that returns me a runtime type, and it's reach type, Lexer arena, right? So I had this sign thing here. Just give it here, right? Did I just... No, never mind. So I guess runtime type equals reach type, print Lexer aria. Okay, let's actually try doing this. Maybe the type is just undefined, right? And then we accept the next token. Or I guess we just do this. If lecture accept keyword lecture int 0. We set type to runtime type integer. If we have float, then we say decimal. Otherwise, we say string. And then I guess we can have a function. Float string and func, right? Func. So we can read the type. Now, if type, then we can, so let's have runtime value. So if there is a type, then we actually expect an assignment. Expected an assignment. Expected an assignment. Assignment for implicit declaration. Lecture accept expect token, and otherwise we only accepted. And I guess I would do value, so read value equals false. And then here we would set it to true, and we would expect the assignment, right? And now if we read the value, then value equals read assignment expression, right? Value, like this. No, wait, assignment. So this is statement equals statement. So this is just 0, right? And if there is a statement, now if there is a type, then we read value and we read statement as this. And then this statement we would say here, we would say equals type. And now if there isn't a type, we infer type from statement to do, right? Implicit. So yeah, here we just say runtime type undefined, right? Because we don't know. read type, undefined. Okay, so per type from statement, right? Okay, but I think this should now like compile actually. So if we say a equals 1.5, a to b float, c float equals 2.0, and d 2.3.0. And now we print A, B, C, and D. I would expect 1.5, 0, 2.5, 2.0, I'm sorry, and then 3.0. Okay. Oh. Yeah, it's because the type, when I use read type, I actually need to... Now I use accept keyword, so what's up with that? So when I accept colon, then I read type. Oh, baby. Hi. So I need to make this work. So now if there is a type, we should do instead, if we accept it, we should read the value. And if there isn't a type, we should expect there to be a value. Right? And then if read value, then we read assignment expression. And then after all that, read assignment expression. I think we need to expect a semicolon. Oh, okay. So if we don't read a type here, so if we don't read an assignment expression, we expect instead we just expect a semicolon basically. Yeah, I think that works after that type declaration. Okay, and give me 1 sec. Yeah, I think now we should be able to read this. So we have 1.5, 2.0, and that's it. And I think the reason for that is that if we have a type, we also... Oh, so... Interesting. So I think what I would do here is I would do static statement. I would say default value, and we'll do for runtime type, right? And now, and I will need an arena. So depending on the type, right? Let's do this. Runtime result. Runtime. No, wait. Statement. Result equals 0 by default, and then in the case of runtime type integer, we just return. We instead do. We push a statement, which is push statement arena. It would be statement type value. Actually, this is just this, right? Result type equals the type. So now actually, if type, then we do this, and that's all we have to do. Result type equals. No, it should be result value type equals type. Okay. And then I guess we should also make sure that this isn't runtime type function, right? And else we would do parser error can't. So type, this type can't, doesn't have a default value. And my errors are actually pretty garbage right now because they don't include context. So when I have this error, it would not say what runtime type, and it also wouldn't really say the line or whatever. So I think that is a problem, but I think I already know what I will do. I will convert those params, Lexer Arena, into a parser, and then I will have some additional state that I can track for printing errors and whatnot. So I think that's gonna do it. Okay, and now what I need is I need to assign this default value. Oh, what I want here is, so here, right? The statement here. Oh no, actually, no. So here, else if no statement, set default value of the type. Statement equals default value, right? Infer type from statement. And now this basically will be like static runtime type, infer type. Undefined for now, infer type correctly. To do infer the type. And now here we would infer it from the statement. Statement value equals this, right? And infer type from the value. And here we would also infer the type from, oh yeah, no, here. So type equals infer. We infer it instead. Okay, should do it. Yeah, and now this is, so this logically should be pretty sound. And then what I think I will do is, I'll break this up into smaller chunks. Read control flow statements. Lexer, arena. Oh, just have this here. Lexer, arena, ren, and then static statement. Oh yeah, and this should also be like this, right? Stay. If statement, then return the statement. Read identifier statements. Lexer. Arena. Okay, and now we would do the same for this. Identifier stay. Right, okay. Sure. Result. Let's just do it like this then. Yeah, so 150020 is what we have. Now the problem here is that we don't infer the type yet. So switch. You should always know what the resulting type is here, so should just be fine to do. Fine. To do actually statically assign this while parsing the tree. Right, and then I guess to do probably remove this function since types should be known at expression parsing stage. Same goes for casting and promotion, right? Promotion. Because we did all the type stuff on the runtime and nothing on the parser stage, and now here we are like inferring the type at the last minute. So some things don't actually have the type, but so for now we just say that if statement type equals statement type value, then we actually know that it is what is it? Right, so we would return statement value type in this case. So this should allow our simplest case to work, where we just have a simple value straight up, right? So now this means that interesting. So declare for D didn't even work at all. It might signify that we have a problem in the declaration here, right? So if we have colon, read the value, right? So yeah, we have this value and this value. I need to run in debug. So we have this value, which is integer 3.0, right? And then, oh, I see what's happening. We do not return the declare. That would make a lot of sense. Okay, so now we can technically have this free here, right? So let's say start implementing static typing. Add support for more assignment, or add support for types in assignment, right? Okay. So now what we need, really, okay. Let's start working on the parser here. So what if expressions were its own type? Okay, let's actually start with struct parser lexer arena. Right. This is what we need, I think. So here now parser arena equals. Oh, AI script has its own arena. Interesting. Okay. Right. I guess I will just store a pointer to the arena then. Parser arena equals script arena, and parser lexer equals make. This could be the pointer to the lexer, right? Oh my god. Read parser lexer. I mean, this could just be here, right? It could own the lexer. I don't see a problem with that. And then parser lexer. I guess this actually would just say parser. And now so those are easy replaces, right? I think we went too much with that. So this all should be just parser like this. Right. Yeah, this is gonna be annoying. Parser arena, parser lexer. Should do it, parser lexer. Oh yeah, because we don't need to do that. Okay, and now arena. Parser, arena. Okay. So those we don't care about. Here we do this. I guess maybe do comma. Comma and comma here. That should cover it. This feels very oopy because I have like those objects, but I actually do have those objects actually. Oh. So let's change this to trigger parser. Now, like this, right? And this would be no. So triggers parser, trigger parser, and here parser star would just be trigger parser. Is this it? Is this it? Or no? Seems to be. Okay, so this was incorrect. Default value actually now takes the parser. Okay. This should be a parser, and okay, so we're pretty close to having this working. Parser. No, this would be parser, lexer, right? I'll reserve the parser, lexer. Okay. So now I would also want to add this as a thing, parser. And what I would do here is I would do printf parser error like this, right? And then I would do print lex token parser lexer current like this. So now I am pretty sure this does new lines. Yeah, okay. And now what I will do for the lexer is actually current and next will be what I have. And next token, what currently is current. So next will be this, current will be next, and lexer current will be the current. Lexer next will be the next. So that's how we will advance. Actually, this allows me to simplify this. So lexer current becomes lexer next becomes the next token. And yeah, it works. What's up now, P? I'm writing the language. Have not named it yet. But it has, we have control flow, we have functions. I'm working on static typing right now. And I think this will be really fucking useful for writing AI and triggers. So pretty epic, I think. So is that it? I mean, peak token would peak the next token technically. Maybe this would be called prev instead of next. Instead of current, right? And then parser error will now take the parser. It's its first arc, right? No? Okay. And then push statement. Yeah, okay. So now it should work. So now I think anytime we have an actual error, we'll get... Do we use Lexer? Do we use Lexer error? Is that something that we ever call? It is. Okay, let's do printf instead. Let's do error Lexer. Yeah, this would be like this. Lexer error. Maybe it would have made sense if... Maybe what I should have done is instead of having Lexer and parser as separate types, is just have them as one type. That would make a lot of sense, actually. But I don't know. Or whatever. That's fine. We'll just have two different kinds of errors. And now if I have an error, so let's say this should be pretty epic, I think. Because now when we type something really random where we say ISD equals something like this, right? Should now pretty clearly say expected semicolon at the end of expression. Cool. And now this should actually also make a new line. So Lexer, this should do a new line. I think Lexer error should just always print the pref token. Lexer pref token. Say Lexer pref, right? Lexer pref like this. We would say Lexer and Lexer, and then now, okay, one sec, error Lexer. Okay. So for expect and okay, cool. I think that does it. So now if I like write something, right? AI test equals, so C, or I don't know, E equals, let's just actually say P 1.4, right? But I will not do a semicolon, right? It actually says it very early. I don't know. I think what I will actually do, thinking about it, is so in Lexer I will have current, right? But I also have Lex token rev. And so we don't have any prefs here. We don't. Okay. And now Lexer pref is one we would do. And Lexer pref would be. So when we pop a token, we would say pref equals current. Like this. And peak would also return current, I think, right? It would return next. think. Right, yeah. And now the pref is basically the previous token. Pref. So now the reason I do that is because I want... Yeah, that's not it. This is what I was looking for. And if I don't have a semicolon in, it should say this, right? Expected semicolon after expression assignment. So it basically highlights the previous token. I think that way... Well, technically I would want to... I don't know. It feels like I would want to print both. Because this is like a range. It's like from this token to this token, there was an error. Because the previous token expected something on the next token. But for now, let's just keep it as it is. And let's see if parser also does pref. Okay, yeah, it does. And now... Okay, I think I can just remove this for now. We don't need it to print or I guess what I will do instead is I will expose this func. Print token line, print token line and value in. And in the case of, or maybe this would actually be value and line, right? And we really just want the line in the error. Okay. I think that does it for error handling. So let's say improve error handling. Group parser params to a struct. Maybe we didn't have to do that actually. We could instead maybe even merge lexer and parser to one struct, or I don't know, or use what we used. We'll see. We'll see how that goes. And the trigger parser is also now just the correct name. Okay, so let me actually showcase what this language can do. So we have while loops, we have a print statement, we have functions, JAI style. I mean the syntax for variables and functions is like JAI, although since this is a dynamic language, although I think I would want to compile it to bytecode eventually. But since it is dynamic, we can do things like reassigning the functions. That's actually pretty easy, since function is just like a bunch of... It's basically like some value in memory. It's not like... It stores the AST tree. It's just like a pointer to some nodes, right? And that means we can reassign it pretty freely, and that's pretty neat. But we'll see if, when I do bytecode, if we even bother to support that still. But yeah, I have started to add types to the language, but the type system is not yet really in the parser. It's more like a runtime thing, where it only works during yeah. So the runtime, let me show you. This is what do we do? So we create a global scope, which is a runtime scope, and we eval each statement. This is like a recursive function, and depending on what the statement is, it does the thing. So it's basically like we iterate over the abstract syntax tree, and we just evaluate it as it goes recursively. So it's, and we use like runtime scopes for now, and which should use hash maps, but currently just use a list. And we have like runtime value promotion rule, where if you have integer and decimal in one expression, it would promote them and whatever. But actually, that like casting stuff, I would want to handle on the parser side. That way because I want static strong typing, where like it's not really like JavaScript level free, and you can do every error you want. I don't want that. I don't think that's very good. But I also don't want you to have to define every type, right? I don't want you to have to type int unit ID equals 69. I want you to just say unit ID equals Zephyrcore, because this will be an enum, right? Like unit ID Zephyrcore maybe, or something. The unit ID dot Zephyrcore, actually, that would be neat. Unit ID dot like Zerg Zephyrcore maybe, right? Something like this. And this would automatically become an int, because enums are basically integers, right? And I don't want the end user to have to, like, I want all the good stuff, and I don't want all the friction for the user. I want this to not be another AC3 where doing anything requires months of work to actually accomplish it, and even then it's not very satisfying or whatever. It's not the greatest result. So actually, I will grab this and I will add this here. We'll say enum support. That would be neat. So let's say we have started to improve the type system, and we have finished improve error reporting. Okay, we'll say it like this. Enum support can be added before async, and then we have to consider all this. And I guess an enum would be declared like this, where we would say unit ID enum something, right? I guess we don't need that semicolon. I think that would be great. And then you would access it like this, something, or like my enum something. So basically like this. And then the unit ID enum would actually be a implicit global that gets declared by the engine. That way you can do it easy. That actually could be really powerful for behaviors. So if we would want to expose behavior making, so like any kind of passive availability for the unit, This way you could actually dynamically access any unit ID defined in the def file without having to like bother with like any other like dynamic weird, I mean like precompilation or something, meta programming, right? So could be really neat. Like if we can get this language to run fast, I think this will be actually really, really good. Yeah. So that's pretty epic. And I think what I'll try to start right now is the static typing, although I'm not really, no, not this parser. I don't want to look at it. Gross. We can close all this. Can I just close? Huh. Okay, whatever. Just do this then. Holy fuck. Okay, let's just do this. Close all tabs. And now let's open Lexer, parser, runtime, and AI test, right? And I actually want them in this order. So header first, and then parse. We have Lexer, parser, runtime, and the test. Okay, this is all I need. Okay. I think what I will do now is have the I guess one thing is true. So in runtime value is true, right? We could say that value function scope, right? If the scope is assigned, that means the function is set. Currently, it's weird because the function can just be reassigned with like different params or something. We'll have to protect against that. On runtime, ideally. I mean on parser time, so it's statically evaluated, basically. Okay. So now what I do need, I think. So first, I think I would like to. I would like the runtime stuff to be in the runtime file, but that's not possible because we do use runtime type and runtime signal inside of this file. So I don't think it's possible to remove them from here. Also, I would say to consider making expressions its own type. Odd way the structure of the parser is more explicitly error checked, I guess. Parameter type is something I should evaluate now. So now basically what we need to do is we have to make it so each statement has its result type set correctly. And to do that, we will need to set it inside of the Let me think about this. So we'll need a function that returns a statement from a statement that is like a casting thing. So we either, and there would be two cases where literals, they would just directly get casted to the new type, and non-literals would just have something, have like a unary operation prepended that does the casting. Unary style, it's not exactly like that, but whatever. And that way it would signify that, oh, on runtime, before you use this variable, also cast this to this type. And then we would like type check like which casting is allowed. And then we also need to keep track of the types of variables that we declare. And we need to then, for each statement, actually set the results type and propagate it up depending on like the casting rules and etc. etc. So that's what I need to do. But the stream is already pretty long, and this feels like a task that will take an entire stream at least. So since I started it, that's great. But I will do it tomorrow. And yeah, if there are any questions before I go, let me know. And I think this is becoming a real language really quickly. It's pretty great that what it will allow. Because if you think like if we would be to open CMBW, right, and go to MPQ or AI or something, right, we see like AC3 for Terran. All those vars and like multi-runs and having to like you have async, right? That's great, but you have to write in assembly style. What if you had functions? That was always something I wanted to do with the preprocessor back in the day, but I didn't know how to program them. I used like reg expressions, and it was really messy and really error prone and wasn't really good. And it also was compiling to ASC3 instead of like actually being, so it was like actually slower than runtime evaluation, I think. And it was also hitting all the fucking thread limits and whatnot of the game, so it wasn't really bad. But if you see all those like pref Maverick, pref something, imagine if instead of like doing this, you would just say like mining this equals like it just equals 13 and we're done. I guess 1 in this case, right? And that way you would so no, I don't have arrays yet, and I don't know if I want them. As basically I want to avoid any allocations outside of the stack of the program, right? Because that's really fast. That's based on a single arena. It's really fucking fast. But then if I have to like add manual memory, so I actually have a note about this here, right? Consider adding structs, lists, and pointers. But we want to avoid garbage collection, ref counting, and manual memory management. So I don't know, because maybe we just have defer and free, right? But I don't know, because I feel like I would want to hold off on this because this is basically something that would like I don't know how much of the problem changes when we do bytecode. So I would probably want to first like maybe see how slow we are and etc. and then see if we need the bytecode and how does it change the problem and stuff like that. Yeah, and the structs I think could be done, but they would be a value type. Although it's weird because I then don't really know how I would return them, because returning them would require you to like allocate them. And then we would need like pointers and whatever. And language is not really meant to deal with concepts like that mostly. It's meant to be a high level description of what AI does and what like happens in the mission. But I don't know. But we'll definitely see what we like actually need, and like if it's clear that like arrays are needed for the language to function and we cannot simplify it past arrays, then we'll probably add the arrays, right? We'll see. Because like stack structs and stack lists would be fine, but how useful are they? I don't know. It's like you're back to programming C style, low level, right? But then I also don't want to allow things that in practice are really slow. So I'd rather have a default that is really simple and really powerful and doesn't require you to do all those like things. Like, I don't know. We'll think about it. And yeah, this is it for today. So I'll see you guys.